I hope you are able to see my screen. Can you just confirm that in the chat? Okay, great. So before starting Pandas, let me give you some context on what we have already done. So in the last few classes, we have seen an introduction to data science. We have seen that we require Python as our base language so that we can understand and we can implement certain things. In that process, we looked at operators and control structures. We looked at data types. We looked at functions and modules. And then we went to packages, right? So one of the basic packages that we saw was Numpy. Numpy is a very foundational package within data science, especially when we want to do mathematical operations. Okay. And within Numpy, we saw multiple things on how to create arrays, how to manipulate them, how to change them, how to do mathematical operations, how we can use inbuilt functions. We can also do something called as broadcasting and vectorization. Okay. So after all that, we are now moving to the next step, which is looking at the next data science package. And the package that we look at is Pandas. Okay, so Pandas is again a very famous data science package, and it is very foundational package. It is so important that in every data science project we'll be using Pandas. Okay, or mostly, at least for the 90% of the time, for every data science package we'll be using Pandas. So let me go ahead and see, tell you more things about Pandas. Okay, so this is what the symbol for Pandas look like. It's like a series of these lines. I think these are bamboo lines because pandas, the animal pandas likes to eat bamboos. I am guessing that this is a representation of that. Uh, what is Pandas? So Pandas is basically a Python library for data analysis. And when I say data analysis, then it is used in the entire pipeline of data analysis, starting from data exploration to data cleaning to data transformation, and even things like feature engineering and preparing the data for our scikit-learn or preparing the data for our machine learning algorithms. Many of those things we will do in Pandas. So Pandas is basically a very wholesome package, a very useful package that goes from the beginning phase of even reading data to giving the data to our modeling phase and so on. Okay, Pandas is built upon Numpy and SciPy. So many of the functions that we saw in Numpy, uh, Pandas is built upon that. Okay, so you would notice that many of these functions we would call from Pandas, they are actually Numpy functions. Even internally, Pandas uses Numpy for handling its rows and columns, and there are a lot of similarity between how the data is being accessed. Okay, and we can definitely make use of that. The key features of Pandas is we have integrated indexing. That is again a very important feature. Integrated indexing means you don't have to, uh, or there are multiple ways to access data. There are multiple ways to access data using indexing within Pandas, and they are very much integrated between the rows and columns of the data. So I'll show you different methods like location-based method, index-based methods, condition-based methods, where we can extract several features out of the different data sets. Okay, and that is only possible because we have a very nicely integrated indexing within Pandas. Okay, we can also do a lot of descriptive statistics. So statistics like how our data is distributed, uh, what is the mean, what is the standard deviation, what is the quartile range, and so on. So many things are very easily accessible using Pandas. And further, it provides very useful functions for data pre-processing and feature engineering. So maybe I can quickly note down what are the key steps that we would do in any data science project. Okay. So if you look at any data science project, we would want to do these things. We would want to do exploration. We also call it EDA, exploratory data analysis. We would want to do visualization. We would want to do pre-processing. feature engineering, validation, testing, and deployment. So generally, these are the basic steps we would want to do in most data science projects. Of course, the list does not remain the same. Sometimes we may add more things. Sometimes we may say that, okay, one of the steps is not important at all. Or sometimes there's an overlap between the multiple steps. So nonetheless, these are important steps in the life cycle of a data science project. And within this entire process, we can use pandas for data processing. We can use pandas to some extent for visualization. We can use pandas for pre-processing, for feature engineering. And till here, we can use pandas. Finally, we take pandas data and then we pass it to models like scikit-learn and Keras or different cases depending upon the algorithm that we are wanting to use. We can take it to modeling, validation, and deployment. But in this entire initial phase, pandas is very foundational. Okay, so I've talked a lot about pandas. Let me go deeper inside, and we'll see how pandas works out. Okay, so there are basically two data structures within pandas. One is called as series, and one is called as data frame. Okay, and based on these two data structures, pandas works. Okay, so let's look at an example of a panda series object. A panda series looks basically like this, where you have, so this looks like a column in your Excel data. This is the name of the column. This is the row numbers. So row number 0, 1, 2, 3. And here are different values for this data. Okay. The way we can create a data frame the way we can create a series like this is by using this command. We can call pd.series, and that is the function that we'll call. In the first argument, the first input will provide the values that we want, Index is equal to, if you want to change the index, we can have this index that you want, or we can give the name, that is the name of this column. Okay, just give me a second. Okay, okay, right. So we can use pd.series, which takes values as input, index as input, name of the column as input, and let me show you how I can do that. So for this case, when we want to write this column here, we could give the data as follows. By giving an input like this, we can create these apples. Now you may have noticed that I did not specify index, because as I see here, index is the standard 0, 1, 2, 3. So even when you don't specify index, pandas will take a default index starting from 0 and so on. So generally we will define index only when we want special indexes. Special indexes like the name of the row should be there as an index input or so on. Now within series, we can access the different data using two kinds of options: a location-based option and an index-based option. Okay, a label-based option and an index-based option. We will look both of these when we go to the notebook within. When I show you the notebook, then I will explain both of these ideas. Going ahead, let me show you what a data frame is. So a data frame is the second kind of structure that we have within Pandas. This data frame can be formed using multiple series. Okay. So here I have series 1, series 2. And if I join these two series together, then I get a data frame. Okay. So as you can see in this data frame, there are two columns. The name of the first column is apples. The name of the second column is oranges, and they have equal number of rows. Okay, the rows are 0, 1, 2, and 3. And these are the different values that we have for them. Okay. So the way we can create, again, the way we can create data frame, let me shift back to the notebook and then I can show you, demonstrate how that is done. Okay. I hope you can see my screen. So I'm presenting my notebook now. And let's look at, these are the different things that we'll be doing within the notebook. We'll look at data structures, we'll look at basic data frame operations, how to read data set, how to do descriptive statistics, some introduction to data cleaning, data visualization, filters, groups, and merge, finally parsing timestamps. Okay, so let's go ahead. Uh, Within data structures, how do we create pandas? Okay, so one step before creating pandas is we need to import pandas. Okay, so we import pandas using the command import pandas as PD, and PD is the alias or the short name that we'll be using to work with pandas. And generally, PD is the what do you say? PD is the common acronym that people use throughout. It's very standard. You can change it if you want, but I would suggest that let's keep it the same thing so that your code becomes more readable. Okay. So we import pandas as PD, and we see here we create a variable series ser is equal to pd.series. Again, note that this is a capital S and not a small s. Pd.series, and we pass here two inputs. The first input is a list of items, 100, foo, 300, bar, 500. And the second input is again a list of strings, Tom, Bob, Nancy, Dan, Eric. Okay. So if you remember from the slides, I showed you the first input is basically the values. The second input is the index, right? So now when I execute this, you can see here that I have a variable. When I write ser and just execute this cell, you can see here that this has the indexes as Tom, Bob, Nancy, Dan, Eric, and these are the values present within that object. Okay, so you can imagine this as a column, but we have not given any name to this column. So imagine this as the unnamed column with the values 100, foo, 300, bar, and 500, and these are the different index values. So your index values need not always be simple numbers. It can be text like this as well. Okay. If I want to access the index values, I can use ser, that is the name of the variable, dot index. Okay. When we do ser dot index, I can get a list of these items. Okay. So I can get Tom, Bob, Nancy, Dan, and Eric as here. Okay. Further, I can use the location command .loc, which is basically a label-based location. Okay, so how does this work out? So if you look at here, ser.loc, I open a square bracket, I close a square bracket, and then inside I put a list of index values that I want to extract. Okay. So in this case, since I want multiple index values, I'm again putting a list. If I wanted just one value, so let me show you a case of just one value. If I want, let's say ser.loc, in this case, I want to extract, let's say Dan. So I can write Dan inside and I execute this. So when I execute Dan, so I can get access to the first element here, or I can get access to the element corresponding the index of Dan. Okay. If I want multiple things, so let's say I want to extract two things, Nancy and Bob, then I have to put it as a list of items. Okay. So ser dot lock dot location, and within square brackets I put again a list of items of Nancy and Bob. So when I execute this, you can see that I get Nancy and Bob. So Nancy has the value 300 and Bob has the value 4. Okay. Going ahead, this is one way of accessing the items. We could also access the items using the index to them. Okay, so like Numpy or like other options in list, Pandas also has zero-based indexing. That means this is index 0, index 1, 300 is index 2, index 3, and index 4. So we have index 0 to 4. When I access SER and then I access a list of items here as 4, 3, and 1, I'm able to access 4. With 4, I'm able to access Eric as 500. With 3, I'm able to access Dan as bar. And with 1, I'm able to access Bob as 2. Okay, so these are the selected items that I get in the outside. Okay, let me go ahead. We can also, instead of this, get index location, that is ser.iloc. Iloc is index location, and you have to give the index of the value. So in this case, I want to get the index 2. So this is 0, 1, and 2. So when I do ser.iloc2, I get this value as 300. Okay. Notice with lock or with lock, especially when trying to get multiple items, we found that we get a series as a return value. Okay, this is also a series. This is also a series when we're trying to get multiple values. But when we're trying to get single values, when we're trying to get here just a single value here and even here, we can see that it returns to us just the value part, just the element value. Okay, not the series. Okay, so an interesting thing to note that may be useful sometime. Going ahead, we can use the in command. So just like in lists, we could use is something is there in a list or not. Here we can write is Bob in series. So when we write Bob in series, we know that Bob, the index Bob is in series, so it gives us the value true. Okay. Okay. Let's try to do some mathematical operations here. So if I again print the value of series, I can see that this is a series item with multiple indexes and multiple values. If I just do series.2, okay, series multiplied by 2, what happens is each element here gets multiplied by 2. So if it's a number multiplied by 2, so 100 multiplied by 2, we get 200. If it's a string, we saw that, okay, I have not disabled the annotation. Let me disable them. Okay. So if we write a string and then multiply it by 2, we know within Python, even when we were operating for strings within Python, we saw that when strings are multiplied within Python, they get duplicated as many number of times. Okay. So when you write foo and you multiply it by 2, you get foo and foo. Okay. The number 300 multiplied by 2 gives you 600, bar gives you bar bar. Okay, I have disabled. Okay. Let me clear that once again. Okay. So it is able to give us this option. Okay, multiplying by 2. Further on, uh, instead of multiplying it for the entire series object, we can do it for a selection as well. Okay, so here we are taking SER series and we are doing a selection over that. So we are going for indexes Nancy and Eric, and then we are raising it to a part. Okay, so we know that the raise to operation, that is the raise to operation, does not work on strings. So it will only work on numerical values. So first case, we are taking the indexes Nancy and Eric, which gives us the location or which gives us the value 600 and 1000. And then finally we can, sorry, not 600 and 1000, it will be 300 and 500. And then we can take 300 and 500 and do an exponent over it. Okay. So I hope these are very basic things that we can do with the series data structure. Okay. Let's go ahead and also look at the data frame. So Pandas data frame is basically a two-dimensional labeled data structure. So two-dimensional means there are multiple dimensions. On the x-axis or on the rows dimension, we have same like indexes, and at the columns dimension, we've got multiple series. Okay, so let us look at this example when we are joining two series together. So maybe can you, as a question to get you guys involved, can you tell me what is the data type of this variable D? Yes, the data type of this variable D is a dictionary, and we can know that because we can see this open curly brace, close curly brace, that is hint 1. Second hint is we've got a key value pair. So here the key is 1 and the value is the series object. Okay. In the second element again the key is 2 and the value is the series object. Okay. Excellent. So if you look at the value of the first object 1, it is a series object, and here this is the values of the series object, that is 100, 200, 300 are the values, and the corresponding index is apple, ball, and clock. Okay, and you see the name of this column will be 1. Let me show you ahead. The second item has the name 2. It is a series object with 4 elements: 111, 222, 333, 4444, and the index values are apple, ball, Cyril, and Nancy. So when we take a dictionary object like this and we say to pandas that create a data frame out of this, so it says pd.dataframe. Again, note these values. For the data frame we have a capital D and we have a capital F. Okay. So generally, uh, maybe let me show you a hint as well. When I'm writing things in my notebook, I would write, let's say, pd dot, and instead of writing data frame, I will press a tab on my system. So once I press a tab, it gives me a list of uh, a contextualized list of what are the possible options. Now, when I start writing capital D, okay, you can see it automatically shortlists the things that start with a capital D. So I generally, especially when I'm using a Jupyter notebook, I use this feature a lot so that I don't make any spelling mistakes as well. Okay, so I can just press enter now and I get pd.data. It's just a hint of how to not mess with the capitals and spellings and so on. So we call pd.dataframe and we pass this dictionary as input. Okay, and the output of this goes into the variable df. Now df is a very standard. So generally, people use this a lot. Df it stands for data frame. You can use any variable, of course, but I've seen a lot of people use df as data frame. So you can have different variations of that, like df train, df test, and so on. But let's look at df. So when I print df, you can see here that it prints 2 columns and 1, 2, 3, 4, 5 rows. Okay, 5 rows and 2 columns. The names of the rows are here. So we give apple, ball, clock, and apple, ball, Cyril, and Nancy. So here it took apple, ball, Cyril, clock, and Nancy. So basically it took a union of these combinations. You can also see that this list is in an alphabetical order. So we have apple, ball, Cyril, clock, and Nancy. These are the index values. Additionally, it took these key values here, 1 and 2, and gave them as names of the columns. So we have 2 columns, column 1 and 2. If you look at the values here, so 100, 200, 300, they are in the column 1. They exactly correspond to the labels apple, ball, and clock. So for the label apple, for the index apple, we get the value 100. For ball, we get 200. And for clock, we get 300. For the 2 items that one did not have, okay, so one did not have Cyril, it did not have Nancy. For this, Python automatically replaced by NaN. Do you know what NaN stands for? Okay, excellent. So NaN stands for not a num or not a number. And for the most part, what NaN also represents, it represents missing value. Okay, so since this was a missing value and Python did not know what to do with it, it replaced with NaN. Yes, null is also what we call here. So null value or not a number or missing value, all of these are corresponding to the same things. Okay, so when Python does not know or when Pandas does not know what to populate here, it does not show us an error. Okay, thankfully it does not show us an error. It just replaces it with an NaN value. It stands for not a number. Let's look at the second column. Here we have the column 2, which has the values 11, all these values. And we can see that they are for apple, ball, Cyril, Nancy. So it gets populated there. It just does not have an item for clock. Okay, for the index clock, it does not have anything. So Pandas automatically replaces that with an NaN. Just like series object, we can access the index using df.index. we can get the values here of all the index values, that is apple, ball, cereal, clock, Dancy. If now additionally, if you want the columns, okay, if you want to know how many columns are there, what are those values, what are the names of the columns, we can use something like df.columns. So when we do df.columns, we can get here both the columns 1 and 2. It gives here 1 and 2. Further, we can create a data frame. So this was one way of creating a data frame, right? pd.dataframe, and we pass d as the input. Additionally, we can do some shortlisting while creating the data frame also. Now I'm creating another data frame with d as input, but I'm specifying certain index values. Okay, so the index values I'm specifying here is Dancy, ball, and apple. And you see, interestingly, what Pandas does is it takes the same D. So this D has a lot of information, but it is only choosing the information of the indexes Dancy, ball, and apple within this order, within the order of Dancy, ball, and apple. So we see that the first element becomes Dancy, second is ball, third is apple, and correspondingly the value that belongs to 1 and 2 as per this dictionary that get assigned to this new data frame. Okay, so we are able to shortlist which indexes we want while creating the data frame also. Okay. Additionally, we can also shortlist which columns we want. So here I am telling that the columns that we are interested in is 2 and 5. Now you would know that we have values for the column 2, but we don't have anything called as 5. What does Pandas do? Pandas gives us 2 and 5, and 5 where it does not have a value, it replaces all of them with missing values. So these are again multiple ways of using the same dictionary to create new data frames. You would see that since I'm directly printing the data frame, it prints it in a very intuitive format. So this is a very neat format, at least much better than this format when I'm just printing the DF. If I just allow Pandas to do the printing object, that is by keeping the last line of a cell as a variable, a Jupyter notebook automatically prints it out. Okay, and here we can see that the rows are shaded with alternate shading, so we can know or we can identify clearly between rows. We have bold for the names of the columns and for the names of the indexes. We have this line here. We have neat separation between the data. So all of these are very interesting to see, and especially when you're looking huge amounts of data, it becomes more readable in this format. Okay. Going ahead, we can also create a data frame from a list of Python dictionaries. Okay, so if you look at here, this variable data, this is basically a list object. Okay, now this list object has multiple inputs. There are two inputs. The first input is a dictionary with two values, Alex and Joe, and values 1 and 2. The second input is also a dictionary with three key value pairs as Emma, Dora, Alice. Their values are 5, 10, and 20. So when we take this data and we tell Pandas that create a data frame using this input data, just note what it does. It takes the first element and assigns it to row 0. It takes the second element and assigns it to row 1. Okay, and all the key values, all the key items, okay, all the keys, it converts that into column names. So Alex, Joe, Emma, Dora, and Alice, they become the names of columns here. Correspondingly, for the 0th row, the values 1 and 2 get assigned to Alex and Joe. And for the things that it did not know the first input, we are not specifying Emma, Dora, and Alice. So Pandas keeps their values as NaN. For the second row, the second item here goes for index 1. Here again, Alex and Joe are not defined, so Pandas puts NaN. And 5, 10, and 20 for Emma, Dora, and Alice, it assigns here. Okay. We could also, instead of, so here we did not specify, in both cases, we did not specify the name of the columns, but we're interested to specify the name of the columns. We can pass that as an input called as index, which gives us the name of columns. So here we are passing a list of items, and we need to have as much list as we have for as many rows we have. Okay, so we have 2 rows. So the first row, it gets assigned the name orange. and the second row gets assigned the name rent. Going ahead, just like before, we can do shortlisting also. So we can use shortlisting of columns. Here we are using Joe, Dora, and Alice, and only Joe, Dora, and Alice gets created within this data frame. Let me see the slides once again. If there's something we can do directly. Okay, we need not go to the slides. We can directly work our way within this notebook itself. So I hope how to create a series, what are series, and basic operations of series we have seen. We have seen how to create a data frame and basic operations of data frame. Of course, there is a lot more to learn about series, and there's a lot more to learn about data frames. So we can spend a lot of time here just trying to explore how they are created, how they get access, and so on. But let us keep a fast pace where we can move to other concepts. Just like Numpy, Pandas is also a huge library. Uh, till now, after so many years of using Pandas, till now I'm every day when I open Pandas, I learn new things about Pandas. So this learning will never stop. Okay, so let us move ahead so that we can keep focus on our journey of data science. And as and when you get more practice of Pandas, this you can learn more and more as you keep practicing. Let me go ahead and let me do some basic data frame operations. So when I write df, I can see that this was the data frame that we stored last under df. We have the columns 1 and 2, with these indexes and these values. Okay. If I want to quickly verify what is the type of this variable df, I can write type of df, and we can see that it returns to us a string like this, which says that if it belongs to pandas, it belongs to core, it belongs to frame, and this is the type of the variable data frame. Okay, so we know that pandas is a huge library because there are multiple packages, and it has to be a huge library. There are actually hundreds of different functions within pandas. Uh, so the type of df here is a data frame, and when we take the type of one of these objects, okay, so to get one of the columns here, I can write df, and within square brackets, I can access the name of the column. So here the name of the column is 1. When we do df1 and its type, we can see that it is actually a series object. Okay, that is what we get here, series object. Now we can access, as I said here, we can access the column by writing df1, and that is within square brackets, write the name of the column. And if this column is a string, we have to write the name of the column within single quotes. And when we do that, we are able to extract the series object. Okay, so as we saw earlier, the series object, we can see that these are the indexes, and these are the corresponding values. This is the name of the series, which is also the column name 1, and it gives us the type. Okay, so it tells us based on the data that it sees that there are floating point values. So it says that okay, the default data type for this series will be a float 64. Means there will be float values. Can you tell me how can I extract the second column here? What code should I write so that I can get I can print, or I can see the second column here? Okay, yes, we have to write df2, but notice an interesting thing. We cannot write df2 here. 2 is not a variable name. 2 is the string here. So it has to be written within square brackets. Okay, so when you are within square brackets, and you have to write it as a string, that is within single quotes. So when you write it within single quotes like this, you get 2. In fact, you can also write it within double quotes. Okay, so as we were doing pandas, we were doing strings earlier, we saw that Python does not differentiate between single quotes and double quotes. Okay, so it would do well to use one of these two days. So you can write df2 and you can get the second column. So you can see again that that 2 is a series object. The name is 2, and these are the different indexes, and these are the different values. Now we can create a new column. So we are creating a new column df3 by simply writing df and then the name of the new column and the operation that we want to do. Okay, how do you want to create 3? So I want to create a third column such that it is basically a multiplication of all the elements of column 1 with all the elements of column 2 in an element wise fashion. So when you write df3 as df1 multiplied by df2, you can see that the first element here, 100, multiplied by the first element of 2, which is 111. When you multiply these together, you get 11100, and that becomes the first element of this column 3. Similarly, you can see 200 multiplied by this gives us this value. NaN multiplied by 303 gives us NaN. So not a number, Pandas does not know if this is a missing value. How can I multiply these two numbers? Okay, so when it cannot multiply, it fills it with NaN. So it fills it with not a number again. So in all these three cases, where one of the items is not a number, we get the multiplication as not a number. Okay, so that is one way that we can create a new column within the existing data frame by doing a certain operation on using the first and the second column itself. Okay, we can do more things. We can create a new column. So let me first show you this slide, and then we can come here. This cell, and then we can come to this one. So here I'm creating a new cell called as df flag. Flag is the name of this new cell, and I want to populate it with Boolean values. So I'm putting a relational operator here. Okay, I'm putting a condition operator here, and depending upon the condition, if the condition is satisfied, I will have the value true, and if the condition is not satisfied, I will have the value false. What is my condition? My condition is if df1 is greater than 250. So let us look at the column df1. So this is not greater than 250, so it will be a false. False. NaN, it cannot compare, so it will give a false. 300 is greater than 250, so it will give us a true. And then NaN greater than 250, it cannot compare, it will give us a false. So these values, based on the condition here, it creates a new column called as flag, and it populates it with false and trues based on this column. So creating a new column is very easy within Pandas. You just write df and you write the name of the new column and then what operation we want. So let me see if I can create a new column called as zeros. So I write df and 0 is the name of the column, and I populate that with all zeros. Okay? And when I write that, I can see that I have added a new column called as 0, and the values within this, the values that I want to populate here is all zeros. Okay, so Pandas takes this value 0 and populates it for all the different index values. Okay, so depending on how we want to create, so now we have seen three ways of creating a new column. First is by doing some operation on the columns. Second is by writing a Boolean operation, and third is by writing a scalar value. Okay, we can also write a list of elements, and that will get assigned here. Okay, here we see that each of these items is a series item. Okay, each of these columns that we added is a series value, and when we attach it to our data frame, it just gets joined as one of the additional columns. Now there are ways where we can remove columns. So if I do 3 is equal to df.pop3, what will happen is from the data frame df, it will take the column 3 and will remove it out, and it will populate into this variable 3. Okay, so when I remove it out, it means df will no longer have this variable, have this column as 3. Let me show you an example. So here when we write 3 is equal to df.pop3, this column 3 goes into the variable 3. If you write the variable 3, we can verify that the variable 3 has the column 3. It has the values of apple as 11100, ball as 44400, Cyril, clock and Nancy as NaN. So this is basically this column. Can you tell me what is the type of this variable 3? Okay, it is not a dictionary. It is not a float. Okay. So the type of the variable 3 is a series object. So this variable 3 is a Pandas series object. And this series object has a data type of float. It means that this series object has index values and has values here that it is populated, and these values are float. But the type of 3, like if I do something like this, so I write the type of 3, you can quickly see that the type of 3 is a series. Okay, and this series is made from this data frame. Okay. Anyways, now that we have popped the value 3 here, if you write df, if you execute df, you can see that this df does not have the column 3. Okay, this df does not have the column 3. Okay, it has been removed out and it has been pushed into this variable 3. So that is one way of deleting or removing a column. We can also delete or remove a column using the del command. So write del df2 will basically delete this column too. So the difference between pop and delete is when you're doing a pop, you can at least take the value and assign it to a different variable. Rather, when you do a delete, you cannot assign it. It simply gets deleted. Okay, so here when we do delete df2 and I execute this, and then I see the value of df, you can see that it does not have the column 2. Okay, it just has the column 1 and 0. Okay, now we can do some more things. If I want to, I can insert columns in between. So here we are trying to insert a column at location 2. So this is location 0, location 1. In fact, let me try to add it at location 1. So if I try to insert at location 1, I have to say what is the column name. So the name of the column I'm giving is copy of 1. Okay, and then it says what should be the value. We say the value is df1. So I'm just taking df1, which is I'm just taking this column 1 and creating a copy of it within the same data frame and inserting it at location 1. So when I execute this, you can see here that this is location 2 or column 0. This is column 1, this is column 2. So at column 1, we have added a new column, copy of 1, and its value is populated using df1. So it's basically a copy of this thing. We can further create additional columns by doing certain more interesting things. Okay, so here first I am accessing df1, and within df1 I am accessing only the first 2 elements. Okay, that is index 0 and index 1. So when we do it this way, before doing here, let me show you how we can do that. So if I write df and I write 1, okay, you see I get the entire series object. But if I'm just interested in the first 2 values, I can further put again a square bracket and write colon 2. And when I execute this, I can see that I can get access to just the first 2 elements, 100 and 200. Can you tell me what code should I write here so that I get the last 3 elements? What code should I write here so that we get the last 3 elements? Okay, so you're right. We can write 2 and colon, and when we execute this, we are able to get the last 3 elements. Okay, so interestingly here, since we know that there are just 5 elements, if we start from 0, 1, 2, if we start from index 2, we'll be able to get the last 3 elements. But there is also another way of doing it. So as many of you are writing now, let me write that. I do -3. And then I execute this, I'm able to get, to do -3 colon. So if I say write -3 colon, then I can get access to the last 3 elements without knowing where the index starts from. Okay, without knowing where the index starts from. So one question someone asked is how to interchange the columns. So I'm guessing what you mean is I want column 0 as copy of 1, and I want to take column 1 on the other side. So how can I take this column to the left and this column to the right? Okay, let me try that. I'm not sure. So we can see df, and this is what df is. If I write df dot columns, these are the 3 columns that I have. So let me choose the columns. So I want copy of 1, and then I want 1, and then I want 0. So if I do this, I can see that the resulting data frame has the first column as copy of 1, the second column as 1, and the third column as 0. Okay, I can do this by using something else also. I can write df, and within square brackets I can write the locations, that is 1, 0, and 2. Okay, so I'm not able to access with locations. Let me try here. Okay. Had we not done this earlier? Let me see here. Okay, we had done this with the series item. Okay, with series we can do, with columns you cannot access with the index values. So in that case, we are just left with this option. So you can take the order of the columns that you want, and once you have the order, you have ordered in the right format, then you can store it in df. So if I write df is equal to this, I'm rewriting df, and now when I'm rewriting df, it has the new order of columns that I want. So basically we have swapped these 2 columns, 1 and copy of 1, we have swapped with each other by writing in this new order. Okay, so that is one way. I am sure there would be definitely more ways of doing this, but this is the easiest way that I could think of on how to interchange columns. Okay. Let's go ahead. Okay, so we saw ways of how to select a subsection of one column. So depending on one column, and we saw how we can write a smaller section, or select a set of items from this column. We could also it's just printing like what we want, but we can save it. So in this case, when I write df is equal to this, I've actually saved it into the new variable df. In the first case, okay, when you just do something like that, it creates a new data frame, but you're not capturing anything. You're just printing the value. But now in the second case, when I'm writing df is equal to this, it just copies into this variable, and now it saves the value. Okay, so for all future exercises, for all future after this point, df will have this new value. Okay. Now I'm creating a new column called as df1 upper half, and this 1 upper half will be made using this idea. That is, I take df1, and using the first 2 elements, I write that as 100 and 200, and then following that, since I'm not specifying anything, it fills with NaN. Okay, so that is again another way of creating series and data frames and adding new columns to the data. So with this, we have done basics of series and data frames. I don't want to start the next section just right now, because this will be, so from here onwards, when we want to do more, or we want to learn more about pandas, we will take an actual data set. So this is the movie data lens, movie lens website data. And when we look at this data, we'll be able to learn a lot from that data in terms of how to manipulate the columns, how to manipulate values, what all pandas can do. So we'll take this as an exercise from the next class. Today we will stop here. Okay. So maybe if you have, since I have another 5 more minutes, if you have some questions, you can post it up in the chat. Else, what I could actually do is I could take some examples from Numpy and I can show you. Okay. So let me share my screen once again. Okay, task. In fact, just yesterday I gave some tasks, and you will get that assignments. Let me, in the meantime, show you one example here. Okay. Let's say this is what we want. We want to print. Okay. Let's say we want to print this exercise. We want to print the values like here. That is 1 square plus 2 square plus 3 square plus 4 square, where x raised to y means y to the power of x. As an input, n is passed, so the summation up to that element. So basically, the user will put the variable n, that is the value of how many elements you want the sum for, and then our program should give these values as output. So if my user puts the value, let's say user puts the value n is equal to 3, then my program should give the output as 1 square plus 2 square plus 3 square. So that is 1 plus 4 plus 9, which is 14. If the user puts n is equal to 4, then my output will become 1 plus 4 plus 9 plus 4 square, which is 16. And that gives me the output of maybe 30. So this is what we want the output to be. Let us write a simple code for that. So first, let us take the variable n is equal to, we'll take input from user. So I'll write input. I'll write enter number. And since I know it will be an integer, I will take int of that. So that will be my variable. That will be my loop. So now for this, I need to execute a loop n number of times. So I'll write for I in range 1 to n plus 1 colon. I start with the variable as output is equal to 0, and here I write output is equal to output plus I squared. So I can write I raised to 2, and then finally I can print the value of output. Okay, so let me quickly run this and try if we have got this right. So if I put n number as 3, we get the value as 14. Excellent. So when we do number as 4, we get the value as 30. Excellent. So this is working out fine, right? N gives the number of times this loop is going to execute. And since I want so depending upon n is equal to 3, I want the loop to execute 3 times because I will have to do 3 summations. When n is equal to 4, I want to implement the loop 4 times. I want 4 summations. And that is why we have this loop running as many times. And since I will be using the value of the iterator, so 1, 2, 3, 4. Since I'll be using the value of the iterator, I'm writing the iteration from 1, starting from 1 and going till n plus 1. Okay. So starting from 1 is important for me, hence we're doing this. Otherwise, we could also do a range of n, and here instead of I. So can you tell me, if I do it range of n, what change do I have to do in this code so that I can still get the same answer? Okay, a quick question. Instead of range being 1 to n plus 1, if I change the range to just being n, what would I have to change in this loop? Excellent. So we would have to change I to I plus 1. Okay. Why? Because now my I will start counting from 0, and it will go only till 1 less the value. So when I put n is equal to 3, it will start from 0, 1, and 2. Okay. And since we want 1, 2, and 3, I can simply do I plus 1 here, and that solves my problem as well. So you can execute this, you put 4, you can see that you get the right answer. Okay. So this was just a very simple example. I have given you access to some more practice problems. And I think Nirja ma'am will make it accessible to you guys so that you can practice some examples. Nonetheless, if you actually want to practice, you can very easily go to the net, go to Google and say practice problems for Python, and you will get a list of problems that you can practice. Okay. So if you really want to practice, you can do it that way, or ma'am will give you some questions that I have provided. You can practice those as well. So with this, we'll stop for today. In tomorrow's class, we will explore our discussion again on pandas, and we'll go more deeper inside taking a data set and practicing some things that we can work on the data set. Okay. Thank you everyone for joining. I'll stop sharing. Nija ma'am, I'll leave now. Okay.
Okay, sir.
Okay. Thank you. Bye bye.
మీకు అసైన్మెంట్స్ వచ్చేసి ఈవినింగ్ లోపు అప్డేట్ చేస్తామండి, మీరు చెక్ చేసుకోండి. అక్కడ లాగిన్స్ లో అప్లోడ్ చేస్తున్నామండి, ఒకసారి చెక్ చేసుకోండి అప్లోడ్ అవుతున్నాయా లేదా అనేసి. ఇప్పుడు వినిపించిందా? ఓకే, నేను చాట్ బాక్స్ లో చాట్ చేస్తాను, చెక్ చేసుకోండి.